This is Unit 6, Operations with Radicals, Day 2. To start off, does the square root of 16 plus 9 equal the square root of 16 plus the square root of 9? Well, the square root of 16 plus 9 can be looked at as the square root of 25. And the square root of 25 is 5. Over on the right side, we have the square root of 16 plus the square root of 9. The square root of 16 is 4. The square root of 9 is 3. 4 plus 3 equals 7. Does 5 equal 7? No, that's a false statement. So, to answer our question, does the square root of 16 plus 9 equal the square root of 16 plus the square root of 9? Our answer is no. Therefore, does the nth root of a plus b equal the nth root of a plus the nth root of b? Okay, if you just replace a with 16 and b with 9, you're going to get a false statement. So, no. When adding and subtracting radical expressions, like we have in example number 2, you must have the same radicand and the same index. So when you have the same radicand and the same index, you can add and subtract radicals. In example number 2, we have 5 radical 2 plus 9 radical 8. At first glance, it doesn't appear that we have like radicands, but we can simplify the square root of 8. 5 radical 2, that's simplified, okay? So I'm going to write that again. 9 radical 8, so plus 9 radical 8, I'm going to simplify the square root of 8. Square root of 8 can also be written as the square root of 2 times 2 times 2. Okay, 2 times 2 times 2 is 8. So now we're going to simplify. Our index in both cases is also 2. So you don't see it, but when you're taking the square root of something, the index is 2. So what we're going to do here is circle, using the jailbreak method, a pair of 2's. Okay? One of those 2's is going to make it out. The other one meets its fate. Then, as we'll see, this 2 right here will stay inside. Okay? So, next step, we have 5 radical 2 plus the 2 that we're taking out is going to multiply by this 9 right here. Okay? So we're going to have 18 radical 2. This guy right here stayed inside. Okay? Now, look at what we have. 5 radical 2 plus 18 radical 2. We're going to add these coefficients here. 5 plus 18 is 23. Our radicand stays the same. Okay? Remember, in order to add these radicals, the radicand must be the same, and it stays the same. So we're going to have 23 radical 2. That's your answer. In example number 3, the square root of 72 can be written as the square root of 9 times 8, which breaks down even further to the square root of 3 times 3 times 2 times 2 times 2. The square root of 27 can be rewritten as the square root of 3 times 3 times 3. The square root of 32 can be rewritten as the square root of 2 times 2 times 2 times 2 times 2. Okay, so you might have broken it down as the square root of 16 times 2, broken the 16 down to 4 times 4, and done it in a different method. But in the end, if you're doing it right, you'll get the square root of 2 times 2 times 2 times 2 times 2. Okay, so now we're ready to use the jailbreak method. Let's start over here, back where we had the square root of 72. Okay, so our index, again, is 2 in each case. We're going to circle pairs. So I have a pair of 3's and a pair of 2's. The square root of 72 now becomes 6 radical 2. The square root of 27 I see a pair of 3's here. I'm going to take that out, and remember there's a minus sign here, so we're going to call this minus 3, and this 3 stays inside. So minus 3 radical 3. The square root of 32. A pair of 2's there and a pair of 2's there. This is going to become 4 radical 2. Now all 3 are simplified, and we can see that we have like radicands, at least in 2 cases, 6 radical 2 and 4 radical 2. We're going to add those and get 10 radical 2. So again, you're adding the coefficients. 6 radical 2 plus 4 radical 2 gives you 10 radical 2. And then minus 3 radical 3. Okay, we didn't have anything else with a 3 as the radicand, so that stays the same. So our final answer is 10 radical 2 minus 3 radical 3. So right now you should try these practice problems on your own, hit pause, and come back and check your answers. I'll put them up in just a sec. First step, did you factor your radicands? Next, use the jailbreak method. Five radical 24 is going to become 10 radical 6. Negative 3 radical 54 is going to become negative 9 radical 6. Now we can see we have like radicands, like indexes. So let's combine them. 10 minus 9 is 1. Radical 6 stays the same. And our answer is radical 6. Remember, you don't really need to say 1 radical 6. You can just say radical 6. Now try number 2. Careful, look, the index has changed. So you have 3 times the cube root of 5 minus 2 times the cube root of 5 plus the cube root of 40. So all of our indexes are the same. Now we're going to break down what we can and combine like radicals. Go ahead and do it on your own, and I'll put the answer up with all the work shown in just a second. So the cube root of 40 is the only one we can simplify so far, so let's go ahead and do that. Now use the jailbreak method. Since the index is 3, I have to circle a group of 3. And remember, only one of those 2's makes it out. And the cube root of 40 is going to become 2 times the cube root of 5. So now look, we have 3 like radicands. We're going to add their coefficients. 3 times the cube root of 5 minus 2 times the cube root of 5 plus 2 times the cube root of 5 will give us 3 times the cube root of 5. So now let's try number 3. Example number 3, the square root of 81 plus the square root of 100 minus the square root of 50. So go ahead and try this one on your own. Hit pause and then come back and check to see if you did it correctly. There are the steps using jailbreak method, and you should have gotten 19 minus 5 radical 2 as your answer. And for your benefit, up here in the top right corner, I've written rules to remember when adding and subtracting radicals. You must have like radicals, the index must be the same, and when that's the case, you add the coefficients of the like radicals. So then just another way to remember it, they must be the same and they stay the same. Moving right along, we're multiplying. In example number 1, we have the square root of 7 times the square root of 2 plus 4. So we're going to distribute the square root of 7. The square root of 7 times the square root of 2 is the square root of 14. Notice your radicands multiplied. Okay? 7 times 2 is 14, so the square root of 7 times the square root of 2 is the square root of 14. The square root of 7 times 4 becomes 4 radical 7. The square root of 14 can be written as the square root of 7 times 2, but 7 and 2 are prime, so the square root of 14 is simplified. So is 4 radical 7. Again, 7 is prime, so you can't simplify 4 radical 7. Therefore, you're done. That's it. Go ahead and try example number 2, and I'll put the simplified version up in just a second. So hit pause, and then come back and see how you did. You should have gotten 3 radical 5 plus 5 radical 2. In example number 3, we have 4 plus the square root of 5 squared. So let's write that as a binomial times a binomial. Go ahead and FOIL that, and then come back and check your answer. There's your first step. Now simplify that. Combine your like terms, and you should have 21 plus 8 radical 5. In example number 4, this radical 2 is over here on the right side, and we're just going to distribute that. Now simplify, and you're done. Example 5 is similar to example number 3. Go ahead and try that, and I'll put the work up for you to check your work with. There's the first step, there's the second step, and it's simplified. 11 minus 6 radical 2. Good job. My example number 6 disappeared, but yours should still be there in front of you. We have 3 minus radical 2 times 3 plus radical 2. Remember, when multiplying, follow these rules above. And now I'm going to work out example number 6, and you can check your results with mine. So go ahead and pause and take care of that. Come back and check. There's the first step. After simplifying, you get 9 minus 2, and 9 minus 2 is 7. So notice this was like example number 5, but we had a minus sign and a plus sign. Notice we're left with one number. Our answer there is 7. Here we are, we're rationalizing the denominator. So to make things short, when, the rule is when you have a radical in the denominator, it's not allowed to be there. So in order to take care of that, we're going to take advantage of something called rationalizing the denominator. What we're going to do here is multiply by the square root of a over the square root of a, and let's see what happens. We get radical a over the square root of a squared, which equals radical a over a. So while we're allowed to do that, and ask questions in class if you don't understand this tomorrow, the square root of a over the square root of a is just 1. So we're really not changing anything, and at the same time we're getting the radical out of the denominator. So 1 over radical a times 1, times radical a over radical a is just like 1 over radical a times 1. But notice how, this is our final answer here, we got the radical out of the denominator. So we ended up with the square root of a over a. For example 2, let's try this, 2 over radical 3. So we have this radical, the square root of 3 in the denominator. That can't be. So we're going to multiply by, just like in example number 1, we're going to multiply by the square root of 3 over the square root of 3. That will give us 2 radical 3 over the square root of 9, which becomes 2 radical 3 over 3. No more radical in the denominator. Everything's simplified, and we're finished. Okay, so that's it for Unit 6, Operations with Radicals, Day 2. Hopefully everything makes sense to you. However, if you have any questions, please make sure that you ask us in class, and we look forward to seeing you in class tomorrow. Have a great night.